But in mathematics, there's other ways to write decimal degrees. So let's say, for example, you have 10 degrees, let's say 27 1/4. So when you see that, 27 degrees, 27.25 degrees. There's another way to write that in mathematics, and it's by using notation like this: degrees, minutes, and seconds. So this would be the same thing as 27 degrees and 15 minutes, 0 seconds. So this is just notation. So write that down, then we'll talk about it. So think about what 1/4 of a degree would look like. That's a tiny, tiny amount, right? Okay? So that's a tiny amount. So what that means is, in terms of this stands for minutes and this stands for seconds, kind of like they do feet and inches, only 15 minutes, 0 seconds. So the reason they use this notation kind of like a clock is because a minute is 1/60th of a degree. Okay, so when you say 15 minutes, that is 15 out of 60, which is the same thing as 1/4. So it takes these things, and so this is 25 hundredths because you're writing it in normal number notation. Minutes are based on a 60 units, so this is 15 out of 60, so that's 1/4. So when you see 27 degrees, 15 minutes, that means 15 out of 60 minutes. Okay? So what you're going to learn how to do is convert back and forth between these two notations. All right? And so to convert this manually, I could just have to convert based on the fact that there's 60 minutes in 1 degree. Your calculator does this for you, and so basically I'm going to teach you how to convert these back and forth just using the calculator. All right? And let's go the other way around as well. So if you start out in, like, let's say you have 10 degrees and 45 minutes. That's 10 degrees, 45 minutes. Okay, well, that's 45 out of how many minutes are there in a degree? There's 60 minutes in 1 degree. 60 minutes is equal to 1 degree. Okay? So that means this is 3/4. This is 45 out of 60, right? What does 45 out of 60 reduce to? 45 out of 60. 15 goes into both of them. 3/4. So that's the same thing as 3/4. Right? So 10 degrees and 45 minutes is the same thing as 10 3/4 of a degree, or 10.75 degrees. Okay, so I'm just showing you how they work manually. We're going to do them on the calculator anyway, but just to kind of show you how they work. So let's take those same two problems and let's type them in the calculator. So let's start with the first one we did, which was 27.25 degrees. So 27.25 degrees, and we're going to go to the calculator and type that in. So now you can see Brooklyn's calculator, so get your calculator app up. Okay, and we have 27.25 she typed in there, which is good. We want to type that in there. And so we want to go to, see where it says angle in blue. There's a blue key, it's catty-cornered to the alpha key. And the word angle, so go back to that just a second, cancel that out there. And if you look above the word apps, it says angle. Okay? So that's how you know we're dealing with angles, is by that color orange up there. So now I hit that again, second apps. Okay, and down there on number 4 it says DMS. That stands for decimal, degrees, minutes, and seconds. Okay, so if you tap number 4 there, it tells you want to convert it to DMS notation. degrees, minutes, and seconds. So now if you hit enter, it says that's 27 degrees, 15 minutes, and 0 seconds. So see how you can easily convert that back and forth on your calculator? Okay? All right, so to go the other way around is a little bit different. And so what was our other problem? It was we started out with 10 degrees and 45 minutes, right? So 10 degrees, 45 minutes. So this time, you're going to want to type in the 10. So just type in the number 10 and that's it. And then go back to apps. Second apps. Second and then angle right there. And then look at these symbols up here. This is the degree symbol, and that's what our 10 represents, is 10 degrees. So tap the degree symbol to put that on the 10. So now we have 10 degrees. Now we want to type in 45 minutes. So type in the number 45. Okay? And then do it again. Go back to second angle. And this time you want the minute symbol. So we have 45 degrees, or 10 degrees, 45 minutes. So now you can hit enter. And there it is, 10 3/4. Now, if you want to see it as a decimal, then you just have to tell your calculator. You could, for right now, let's just hit math and hit decimal. And so we're going to change that to a decimal, and that's 10.75. So our answer, which is the same thing we got, 10.75 degrees. Does that make sense? Okay. So let's try one more. So over here in your notes, Brooklyn, let's do, how about 31.48. 31.48 degrees. Put a degree symbol on it after the decimal. And we want to change that to DMS notation. So how do I change that to DMS notation? So type in the calculator, 31.48, second angle, and you hit enter, and that's 31 degrees, 28 minutes, 48 seconds. So over here in your notes, just put equals 31 degrees, 28 minutes, and 48 seconds. Okay? And so down below here, to remember what you typed in the calculator, you might put 31.48. Put 31.48 right there. And then draw a rectangle with the second inside of it, a rectangle. So in other words, try to draw this button on your calculator and put the little second inside of that, so you know what button to push. Does that make sense? And then the next button you need to push is the apps button. So draw another rectangle and write the word apps inside of it, or angle, whichever makes sense to you, so that when you look back at your notes, you know what buttons to push on the calculator. Does that make sense? Okay? All right, now other way around. Now let's do one like this. So let's do, I don't know, how about 47 degrees and 32 minutes. 47 degrees, 32 minutes. All right, so in your calculator, you're going to want to type in a 47, and then you're going to want to hit second angle and the number 1, the degree symbol. So let's go back to your notes real quick before we type in more and write down what we hit. So here, type in 47, then the second key, then the angle button, and then what did we hit? Choice number 1, which was the degree symbol. So you can either put a box with the degree symbol or choice number 1, something like that, okay? All right, so now we're ready to type in the 32. So after that, you'll want to write 32 over here. And then second angle again. And this time we hit number 2. Okay, so write that over here in your notes. Now we can't see Brooklyn's anymore, but you're going to make 2 more boxes just like this with choice number 2. And then you hit enter, and you'll get your answer. So hit enter, and once again, her calculator is set to give a fraction. You guys remember how to change the calculator? If you go back to mode, hit mode right here and say, hey, I want, let's see, where does that at?
The top one says
Oh, answer. Right now the answer's on auto. If you for sure want a decimal, you hit decimal, it'll give you a decimal every time. Okay, if you want a fraction every time, you can hit fraction. But it's on auto and it thinks you want a fraction even though you want a decimal. Okay? And so our answer is 47.53 degrees. So underneath that, you can write 47.53 degrees. Okay, does that make sense on how to go back and forth on those? All right, so calculator's pretty handy for that. All right, so that being said, let's look at our textbooks at example 1. Which, Brooklyn, if you need your textbook over there, you can grab it. But example 1, I'll write it up here anyway. It's on page 72 in your book. And it says to add 48 degrees, 49 minutes, and it wants to add it to 72 degrees and 26 minutes. It wants us to add those two things. So if you write that vertically, it would look like this. And if we were to do it by hand, it would look something like this. I would add those together. 9 plus 6 is 15. 4 plus 2 is 6. I had a 1 to carry, so that's 7. So that's 75 minutes. And then over here in the degrees column, I've got 10, 11, 12. So I've got 120 degrees and 75 minutes, but remember, there's 60 minutes in 1 degree. So this is really 1 degree and 15 minutes. So if I were doing it by hand, I would go over and add a degree and make this 15 minutes. But that's just to show you kind of what's happening in the calculator, because you're just going to type them in the calculator, okay? So we know what the answer is. So now we're going to go to the calculator and type that in there. So let's go back to looking at the calculator here, and let's type that in. So 48 degrees, 49 minutes. You do not need a parentheses, okay? So 48, second angle, hit the degree symbol, and then 49, second angle, hit the minutes. So everybody stand up with her, okay? Should have that on your screen. Now you just hit the plus sign and type in the other one. So we hit plus and then do 72 degrees and 26 minutes. All right, and then if you hit enter, it's going to give you the answer in decimal notation. Okay, well, they're going to want the answer to be in the same notation they gave it in, so we have to convert that to DMS notation. So convert it by using the number 4 there to DMS notation. So you got 121 degrees and 15 minutes. And you don't have to put the 0 seconds there. Everybody okay with example 1?
Wait, how come it's not? Oh, okay, yeah.
Does that make sense?
Yeah.
Okay, so example 2 in your book is very similar. It's just subtraction. So example 2, on the same page, wants you to take 90 degrees minus 24 degrees and 14 minutes. And so you're going to type it in just like that, just like it looks. So if we go back and look at the calculator again and type that in, 90 degrees minus 20, oh, you forgot your 14 minutes here. Yeah, there you go.
I didn't see it.
It's fine, yep. 90 degrees minus 24 degrees and 14 minutes. So does everybody's screen look like hers? Let's see. Doesn't yeah, make sure that's a minus sign and not a negative. I'm not sure why it's not liking the syntax. It doesn't like that symbol. Really? Is that the right answer? Nope, that's not the right answer. Unfortunately, it multiplied those. Okay, well, let's go back to that again, and let's type in 90 degrees and 0 minutes and see if that helps. if you type in 90 degrees in 0 minutes. Minus 24 degrees 14. Okay, try that. And now that's the correct answer, and change it to DMS notation. All right, so I don't think the handheld calculators make you do that, but for this one it looks like it's going to be a little picky about that. So you might go to your notes and write 90 degrees 0 minutes so that you'll remember you have to type that in on a problem like that. 90 degrees 0 minutes minus. All right, everybody okay with that? All right, so next thing we're going to do is we're going to go to example 5. And example 5 in the book is 5 and 6. We'll probably skip 6 because it's pretty much the same type of problem. But example 5, I'll just put them on the same page. In example 6, you're asked to do cosine of 37.8 degrees, and you're asked to do tangent of 58.75 degrees. And you know what? I'm going to change this a little bit just to practice what we learned. Let's make this, instead of 37.8, let's make that 37 degrees. And I don't know, how about 42 minutes? We'll make the cosine of that. Okay? And for example 6, we'll just leave that as is. So those are both two problems that you're going to just type straight into the calculator, but you do want to make sure your calculator is in degrees before you ever hit tangent or cosine. So that being said, let's go back to that calculator and let's hit the mode button and make sure everybody's, I think it defaults to degrees instead of radians, but if you look down here for angle, you have the choice of radians or degrees. For this lesson, we have not done radian measure yet. That doesn't come till chapter 3. But for now, we want to make sure our calculator's in degrees, okay? And that's an important thing when you take the ACT and you have a handheld. You make sure you're in degrees if it's a degrees problem, or radians if it's a radians problem, okay? So hit done. And your trigonometric functions are right here, sine, cosine, and tangent. So you simply want to type in cosine of 37 degrees, or whatever it was we said, degrees, and then how many, what did we say, 42 minutes, and go back and type in 42 minutes and close your parentheses, or it will close it for you, and then hit enter, and there is that. So I want to refresh your memory from yesterday. What does cosine mean? When you hit the cosine button on your calculator, what are you telling it to do?
Adjacent.
You're telling the calculator, find the adjacent over the hypotenuse for a right triangle that has this as one of its angles. All right, so if you were to draw a triangle, it would be a right triangle where one of the angles was 37.42 and the other one was 90 minus this, okay? And so the ratio of those two sides, when you divide them, you get 0.79, okay? That's what the calculator's figuring for you. All right, so that's your answer, and you can round it to whatever they suggest. I guess we'll round it to 4 decimal places, so our answer would be 0.7912. Okay, 0.7912. All right, so let's type in the other one, which was tangent of 58.75, and this one's just typing in that straight decimal, 58.75. All right. You don't have to put the degree on there, because you know why? Because when we hit mode, we told the calculator to assume it's degrees. Okay, so you hit enter, and now your answer is 1.6479. 1.6479. Now, I would remind you why a cosine problem can never come out to be bigger than 1. Why will a cosine problem never come out to be bigger than 1?
Because it can't be bigger than the hypotenuse.
Your hypotenuse is on the bottom, So your top number of your ratio has to be smaller, right? So anytime you take a small number divided by a bigger number, you should get something less than 1. Tangent's opposite over adjacent, and you never know. The opposite maybe is the bigger one, the adjacent's maybe the bigger one. So tangent, you can get a number bigger or smaller than 1. But cosine and sine should always be smaller than 1, okay? All right, so that's all there is to that. You just type it in the calculator.
That's the lesson.
Nope, that's the last of that example. So next example we're going to do is example 8. Example 8 is secant of 78. Okay, so secant of 78 degrees, well, my calculator doesn't have a secant button. So that's a problem. If I don't have a secant button to hit, what am I going to do? What do you know about secant and cosine? How are they related to each other?
It's the opposite.
It's the reciprocal, not the opposite. Opposite means to change a positive to a negative, or vice versa. Reciprocal means to take a fraction and flip it over, right? So I guess this one, to type it in the calculator, is going to look like this. Okay, because when I want you to think about what happens when you, I'll just make something up over here, and you don't have to write this down, but just to understand why that works. If I take 1 divided by a third, all right, for whatever reason that's not wanting to write. 1 divided by a third. What's that equal? 3. It's 1 times 3 over 1, which is 3. So what happened to this when I put it underneath that? It flipped it over, basically, right? So when you take something and put it in the cosine of 78, whatever the cosine of 78 is, if you take 1 divided by that, it's going to flip it over. So that's why this makes a reciprocal out of this, if that makes sense, okay? Cosine of 78, maybe, who knows what that is? Maybe it's 3/4. So if you were to take 1 divided by that, that would flip it over, and that's what I want to happen because secant's the reciprocal of cosine, okay, if that makes sense. So in your calculators, you don't have a secant button, so you're going to type in 1 divided by the cosine of 78. So let's go to your calculators and type in 1 divided by the cosine of 78, because that's equal to secant 78. And there we have it. And we're going to round to 4 decimal places, so it's going to be 4.8097. 4.8097. Okay? Everybody okay with that? Okay? Next example. We are going to do, we're going a little bit backwards here. We're going to do example 7, which it says to find the sine squared of 14 degrees. Sine squared of 14 degrees. Now remember, this notation is shortcut notation so that you, when you write it on your paper, don't have to put a parentheses every time. Okay? The calculator doesn't work like that. To do it on the calculator, you're going to have to put that thing in a parentheses like this and then square it. Okay? So that the calculator knows what you're squaring. So let's go back to the calculator. And now we've got sine 14 squared. All right, and that's all there is to it. You just write in the number 0.0585. Everybody okay with that example? All right, so now we're going to do some problems where we go backwards and actually find the angle measure. So we are going to look at example 10. And example 10 says that the tangent of theta is equal to 3.152. Now, if this was a sine or cosine problem, my answer would, I'd look at it and go, that's impossible. That's got to be no solution. Because if this was sine or cosine, I couldn't have a number bigger than 1. But since this is a tangent, I'm okay. Tangent problems can be bigger than 1 because you're opposite and you're adjacent. It doesn't matter which one's bigger. All right, now I have to go backwards here. Think about what this means. This is saying I've got some angle, theta. And I'm just going to pick theta to be over here. But this would be my opposite. And this would be my adjacent if I'm referencing theta. So for whatever reason, that area of my screen is not wanting to write. So this is the opposite, this is the adjacent. And so what this is saying up here is whatever the opposite and the adjacent are, when you divide them, you get 3.152. And they're asking you, what angle measure makes that happen? What angle measure will give you an opposite over the adjacent of 3.152? Well, the calculator has, every triangle, every right triangle in the world stored in it. So you can figure that out by telling the calculator to go backwards. And to tell the calculator to go backwards, you have to use the inverse key. So go look at your calculator. And on your calculator, if you look at tangent, right here is the inverse of tangent. That means to go backwards. So to tell the calculator to go backwards, you have to hit the yellow key. So you hit inverse tangent, and then you type in so anytime you hit inverse, the calculator is expecting you to type in the opposite over the adjacent. So that for this problem is 3.152. So type in 3.152 to represent the opposite over the adjacent, and the calculator will spit out the angle measure for you as long as you're in degrees. So hit enter. So the angle measure, this angle right here is a 72. We'll just round this to 1 decimal place. So let's say that's 72.4. Is everybody okay with that? All right, so what do you do if it's a reciprocal function? If it's a sine, cosine, or tangent, you just got to make sure you hit this key first. But if it's a reciprocal function, like example 12, that says secant of angle B is 1.0768. And that's okay to be bigger than 1, because whenever you're doing a secant problem, secant is hypotenuse over adjacent. And the hypotenuse is the longest side, so when you divide them, you can get that, okay? So what this means is I've got a triangle, and I have angle B, and I know that the hypotenuse over the adjacent, when I divide those two things, I get 1.0768. They just want to know what angle would make that happen. Well, I don't have a secant button on my calculator, so how am I going to do this? Well, if secant of B is equal to that, what would cosine of B be equal to? If secant's equal to this, then cosine's equal to the reciprocal of this, right? So the reciprocal of that, since I don't know it as a fraction, I'm just going to write it like this. Okay? So if secant's equal to this, that means cosine's equal to this. Does that make sense? I just took this thing and flipped it over. I mean, if I had a 3/4 there, I'd make it a 4/3. But since it's not a decimal, that's how I can flip a decimal over. Okay? All right, that I can type into the calculator. So on your calculator screen, I'll write this in your notes. Your calculator screen is going to look like this. Inverse cosine of 1 divided by divided by 1.0768. Sorry, my stylus is not working well, so I use my finger. 1 divided by 1.0768. Okay, so that's what we're going to type in the calculator. So let's go back to our calculator screen. And let's type that in. So you'll hit inverse cosine. Inverse cosine of 1 divided by 1.0768. So the angle measure comes out to be 21.8. Let's just round it to the nearest tenth, 21.8. Okay, and that's pretty much everything you have to type in the calculator. There is a, let's see if, yeah, let's talk a little bit.